Okay, any homework questions? Number 6 or number 8? I think what's that page, like 15, maybe 15 or 16 in the packet. But I do want to go over just one thing, just real quick, and then we'll talk about the new stuff. Um, so what I've been having you guys do is kind of like the maximum amount that you would need to do for this. Like you've been like just given the point, I've been asking you to do everything. Like find all the trig functions, find both reference angle and original theta angle. Draw the graph, right? I've been asking you to do the maximum, okay? But I just want you guys, because we haven't done any examples where we haven't done the maximum. I just want you to know, like, if it only asks for like a specific thing, like just one part of that, you don't have to do the whole process, okay? So like, if it asks you to like find the reference angle only, right? You don't even necessarily even need to draw the graph or whatever. So let me just show you like what the bare minimum would look like to be able to find the reference angle, right? So think like, and working backwards from that too, think about like what all do you need to find the reference angle? And again, we find the reference angle by doing that inverse trig function in the calculator, okay? And so to obviously to find the reference angle, we need to know, okay, the certain trig function, and specifically the positive trig function that I can use, right? And that's where you remember the acronym from yesterday kind of comes in handy there too, okay? Well, let's actually start there. So that's and that'll help us kind of guide us along. So you think about this point, like five, and you don't have to write any of this down. I know it's not in your note packet, but like, so think about like -5, 2. What quadrant would that point be in? And then like using this, like you remember the acronym from yesterday, all students take calculus. Kind of that's based on what quadrant it's in. That's telling you the trig function. And again, that stands for all the trig functions, sine, tangent, cosine. So like what trig function would end up being positive based on where this point's going to end up? Sine, because this point, -5, 2 is in, be like there, it'd be in quadrant 2, right? So I know that sine is the only one that I need to find if it doesn't ask you to find all 6. Okay, so that would be kind of the purpose of this acronym, is to kind of like help you in this situation. Okay, and even so too, you might be thinking, okay, so let's draw it, let's get all my side lengths, but you don't even really need to even draw it, okay? Because think about this, to find sine, I need, in that acronym, when we did day 1, we kind of wrote out like what all, or not the acronym, but the ratio, like what ratio is sine, and that would be the y value over the radius. And I have my y value right here. Like if I drew that in my triangle, that would be kind of the up and down side length of my triangle, but I have that. So all I really need to find to be able to find the reference angle is my radius, okay? And you remember you can find your radius just mathematically too, right? It's just your x value squared plus your y value squared under a square root, okay? So that'd be -5 squared is 25, 2 squared is 4, so 25 plus 4, 29, right? And so kind of wrapping it up, so we know that the sine of this point would be 2, right, the y value over r, so 2 over square root 29. And so to find your reference angle in your calculator, it would just be inverse sine of 2 over square root 29. And so again, you can do that without drawing the triangle, without finding all the different trig functions. So I just wanted to show you that because, like, again, just like you don't have to do the maximum, all the trig functions and drawing all of it every time. Okay. And we'll do more practice with that in the review too, where you don't have to do all that stuff, and hopefully that'll help. But just wanted to show you that, just hopefully to make you not as scared. If you are like looking at a lot of this, like, oh, that's so much work. Some of these aren't going to be as much. Okay. With that, let's go on to the new stuff. So we got a new word here. Trig ratios for, how do you think you'd say that? Quadrantal. The key word there being quadrant. Okay, quadrant. So quadrantal angle, new word. Okay. So these are almost like special cases that are not going to work out like as well as some of the other ones did. And our process here is going to be slightly different too. So we got what is a quadrantal angle, and then we'll do just these two problems. Okay. An angle that terminates on an axis. So what does that mean? Well, yeah, and you don't have to draw this because we'll use this for our actual example. But think about this. Like if you start on your initial side, so an angle that terminates, meaning the terminal side ends up on an axis. So that would mean, like, first up, we would have 90 degrees. 90 degrees is a quadrantal angle. We would have 180 degrees, kind of a full half turn would end up on the axis. 270, 360, and all the multiples of that. So like hopefully you maybe see a pattern there. 90, 180, 270, and etc. Right? So like these multiples of 90 would be quadrantal angles. Okay. Or in radians too. So that's something that kids have been confused about today because we haven't graphed a ton of angles in radians yet. In radians specifically, again, you think about kind of like a full turn is 2 pi radians. So like kind of breaking that down into quarter turns, you could also think of that as like pi over 2 radians, or pi radians, 2 pi over 2, 3 pi over 2, 2 pi or 4 pi over 2, etc. Like, so those angles in radians would also kind of be equivalent to those in degrees, right? Kind of our if it's something over 2 or kind of a multiple of pi over 2, that would also kind of be the same thing. Okay. So anyway, so like I said, these are kind of the special case ones that we're not able to draw like the fancy triangle and get all our side lengths that way. So but like the task here is to go from like graphing these types of angles to the trig functions. And so like I said, because we're not able to draw the triangle, we kind of have to go about it like a different way. Okay. Does that make sense? Just the kind of the basic concept of that type of angle. So just the ones that, 90 degree increments. So what would a negative 90 degree angle look like? Just simply, just like we did a couple sections ago, like if I'm graphing a negative 90 degree angle, what would that look like? Positive x to negative y, yeah, on the axis, that's awesome. Yeah, going clockwise, clockwise negative angle, right? Now, there's a few things that are different about that than what we had been doing before, right? You remember before, and again, don't draw this part, this is just for reference. Last couple days, we've been graphing stuff that kind of starts from a point, and then we kind of go from that point to drawing my radius, and then kind of putting my triangle together from there, right? We have a different starting place here, okay? We're almost drawing like my radius first, and we're not given a point, okay? And so what we're going to have to do eventually is think about like, okay, what x, y point would that coordinate with? Okay, and so that's what we're going to get eventually. Okay. And now you might be thinking too, like, okay, how can I draw my triangle from this? Like, again, I said from a point, we kind of just go straight, like that's the key. We kind of have our point here, we kind of go straight down from there to the x-axis. Or if it's down here, we go straight up to the x-axis, right? If you think about that, like, if I'm ending up here and like the kind of final point's kind of at the end of my terminal side here, if I went straight up back to the x-axis, it'd kind of be like right along that, because it's a completely straight line, right? It's a completely vertical line, that terminal side, because it's on the axis. So that's an issue. So you might be thinking like, okay, could I do like this sort of thing to make my right triangle? And you notice that's pretty different, right? Because before, it would like, these are what our triangles looked like. So it would be like, that would be my right angle is over here, and my reference angle is here. Whereas for this one, the right angle would be here, and so it'd be like, which one is our reference angle? How do we like determine that? So basically, we can't do that either to put together our triangle. Okay. So we are just all that to say, we are in a different situation with these special types of angles. Okay. So I have to kind of get rid of that. So what does that mean? What do we have to do? Okay. That means that we're trying to figure out, like, and just kind of in general, like I said for the last one, all that we need to figure out for our trig functions is we need a point, and again, before it was given to us, now we need to figure out where the point is, and our radius. Okay, so that's the bare minimum that we need to put together our trig functions, right? So we need to figure out a point, and we need to figure out our radius. Okay. You guys following here? Does this make any sense so far? Again, different process with given different information here. So I'm just going to tell you, okay, that our radius, well, let me lead in with something else here. So you guys remember chapter 4, logarithms. Okay, you don't have to write this either. But like log base 2 of 4, we talked about that, right? That base of 2. So when the base is shown to me, I kind of use that base. But do you guys remember if I had like log of 100? What would the, like when the base isn't shown to you, what's like that default base? Like that common, like this common log or like the default base? 10, yeah, 10. Yeah. And so like and a lot of times in algebra and in math, we have that sort of thing like that, like a slope of a line. If the slope's not written there, you think the slope is 1. Um, and so in this situation, how that ties into this is um, we have almost like a common radius. So like if we don't have a point, like for the last problems, um, we were able to find my radius because that stemmed from the point that I was given. Okay. But for these problems, I'm not given like a point to go from. Okay. So I just kind of like in this situation, you just fall back on your default radius. And so that your default radius of a circle, if it's not told to you, is just going to be 1. Okay. So we think of that as like our default radius. So if you're not given a point, if you're not told like calculate your radius using those coordinates of a point, we just think our default radius is 1. And we're actually going to use that fact to work backwards then to say where my point is. Okay. So our default radius of a circle on the graph here is 1. All right. So with that in mind, kind of thinking about this then, like, okay, if we kind of drew this angle then like with kind of that kind of circle in mind, right? We kind of have like a quarter of a circle, right? And so then this is can be a tough connection, but like if we have a circle, if this is a circle with a radius of 1, right? And that would be kind of like this. What then would be the coordinates of this point if we think of this kind, again, we're just going quarter turnaround circle, but we can kind of think of the whole thing as a full circle, but like what would be the coordinates of this point if its radius was 1? Tough connection to make here, so if I'm confusing you, no worries. But if that circle has a radius of 1, what would that mean for the coordinates of that point? 0, how about, and it's down low there, so 0, -1? Yeah, no, that's awesome. Yeah, 0, -1, because think about it. If it's a circle with a radius of 1, that would be 1 unit away from my origin, right? And so if I'm down here, if I'm going, like if it was positive 90 degrees, I would be up here at 0, +1. But I went -90, which takes me down here. So that coordinates of that point would be 0, -1. Does that make, that's a tough connection to make. Does that make sense though? If my radius is 1, that's just, I'm kind of straight down from that 1 unit, which puts me at 0, -1. Okay. And so now think about this, guys. I have an x value from that point. I have a y value from that point, and I now have my radius. Which means, again, it's very different from before when we were finding our trig functions. But I have all the information that I need to write my 6 trig functions, okay? Because think about this. On day 1 of 5.3, we kind of laid out all these ratios for all these trig functions, okay? And again, where we got these from was we said, okay, in relation to this angle, theta, we said it was the opposite over the hypotenuse, right? Because that's for sine. But we said that corresponded with the y value for my point and then the value of my radius, right? So the y value of my radius over r was sine. Cosine, adjacent over hypotenuse, or the x value of my point over the radius, right? And so on, okay? So we're using kind of that connection too of these correspond with those particular values, and we're going to use that because I don't have a triangle to go off of here when it's a quadrantal angle, okay? So we still can use those same ratios with those values, except, again, without that triangle to reference back to. So, again, you can always, as you do these problems for homework and as you do these as we practice, you can always refer back to these ratios. So, right, the sine would be the y value over the radius. Again, you can, without seeing the triangle, we can write that. Y value over the radius. Cosine, x value over the radius. Tangent, the y value over the x value. And then, again, don't even worry about writing cosecant, secant, and cotangent because it's just flipped around, right? The same ones, just all flipped around. Okay. Is this making any sense? It's really tough. This is getting deep into it here. But yeah, this is kind of where we're headed with trig. It's no other direction to go. It's yeah. But now, do you guys, so what would be the sign then? Kind of with that in mind, it's just the y value over the radius. So how, using those values then, what would be that ratio for sine? Yeah, the y value, -1 over my radius 1. Yeah, -1 over 1. And then I can, -1 divided by 1 is just -1. And then cosine x value over radius, so x value of 0 over the radius 1. So 0 over 1 would just be 0. And then what would be the deal with tangent? We're going to run into an issue with tangent. What's the deal there? Think about that, putting those values together. -1 over 0. Well, yeah, and why is that? Why is that no good? Can't divide by 0, yeah. 0 on top of a fraction, it's easy to mix these up. 0 on top of a fraction is okay. 0 on the bottom of a fraction is not okay. So we would have to say undefined. Tangent is not really a thing for this particular point, okay? And if you ever forget that, if you mix that up, just in your calculator, do 1 divided by 0 and 0 divided by 1. And like I said, it's easy to mix up. And then again, cosecant, secant, cotangent, we just flip around those fractions. And just be on the lookout here because like for cosine, 0 over 1 is fine. But when we flip that, 1 over 0 now is not fine. So secant is also undefined. Okay. And then for tangent, -1 over 0 is not fine. 0 over -1 is fine. Okay. So again, just be on the lookout. 0 on the denominator. No bueno. Can't do it. Okay. And that's it. That's all. Just the 6 trig functions for these is what we're doing. Okay. Anything I can clear up with that. This, like I said, this can be tricky to grasp. Any questions on that? Let's just do one more, a little quicker, example 2, and then the homework actually is not this. You don't actually have to find all 6 trig functions. This is going to ask for a few particular ones. Okay. Okay, so then last one, 3 pi. 3 pi. Okay, so again, first off, we have to use what we're given. So we have to graph this. Okay, 3 pi. And again, this is given to me in radians, which is also annoying. Okay, so again, anytime, just remember this, because we haven't graphed a ton of angles in radians. You can always convert it to degrees by doing 180 over pi, right? That's always a thing. Okay, but this one isn't terrible. So we can think about this and think about how this would look on the graph. So what do you guys think? 3 pi. How would you describe like what that angle would look like? How about yeah, that's right. And so in terms of degrees, I think maybe 540. Yeah. But yeah, that's right, because a full rotation in radians would be 2 pi. And then we still have one more pi. So like each half, like if it's 3 pi, 1 pi is a half rotation. So it's almost like 3 half rotations is how you can think of that. Okay. Yeah, so that would take me right there. Okay. And there would be my terminal side. Okay. So just like we were doing in 5.1, graphing those angles with those rotations. Okay. But then again, thinking of it too as what do you need for your trig functions? You need radius, which again, not specified as being anything different. So we go with our default of 1, okay? And then in terms of an xy value, because my radius is 1, again, you're thinking like, okay, if kind of radius of 1 as my circle here, if I kind of went from here to here, what would be the coordinates of that point? Thinking one space away from the origin just now to the left, which would take me to, how about, yeah, -1, 0, right? And so again, that's kind of that. You have like your checklist of things that you need for your trig functions. You have your radius, you have your x value, and you have your y value. Okay, I messed that one up. So that is all we need. Okay, does that make sense? Putting that together, and so just fill these in. Fill these in. The math, yeah, putting these fractions together isn't terrible. And again, if you forget, like, what's my letters that I organize? Go back 5.1. I forget what page this is in your packet. Maybe 11, I think, because yeah, 9 and 10 were the ones we did for practice here. Page 11, hopefully you have all those trig functions or those ratios written. You can refer to that. Okay. So put these together real quick, and we'll go over it. And the rest of the time, oh yeah, none of you should have homework to do over the weekend, so because you guys can. Somebody, do you want to just rattle them off for me? Sine. What do we got? Yeah, 0y over radius. 0/1 is just 0. How about cosine? Yeah, -1. Yeah, because it ends up being -1/1. Exactly. Tangent. We got y over x. How about 0/-1, which is 0, right? None of those are undefined, right? Because the zeros are on top. But then which of my inverse ones are going to be undefined? Cotangent, right? And then also cosecant, right? Both of those are going to involve zeros in the denominator when I flip them, right? 1/0, -1/0. Yeah, it doesn't matter what's on top. If zero's on bottom, undefined. Okay. And then secant's fine, right? 1/-1, which is also just -1. Okay. Feel okay, guys? A tough thing to graph kind of why stuff's going on like it is, but in terms of the math, hopefully not terrible. Okay. Now for the homework, real quick, I'll just kind of lay out what the situation is here. A lot easier because each question is just asking for one trig function instead of all of them. And even 9 through 12, you notice, is talking about pi. And again, you're thinking of that pi radians. It corresponds with an angle. Okay. So it's still, pi is still an angle that you can graph in radians. So again, convert it to degrees if kind of but hopefully you remember with pi what that corresponds to, like what that angle would look like. Okay. And so you draw that angle, and then yeah, for 9, 10, 11, and 12, you can kind of reference that with the radius and with the point to kind of write all these. Okay. So for 9, it's just cosine of that angle, tangent of that, secant of that, cosecant of that. Do you want me to kind of start you on that, or do you feel like you can? Yeah, let me, because you'll see actually 9 through 12, it's kind of convenient how it went here with my examples. So again, we got to think about first with pi. Again, think first about the angle of pi, how graphing this angle is going to look. So if I'm just going 1 pi, where would that take me? I'm just going 1 pi. Where would that take me in terms of like rotations? 180 degrees it corresponds with, and like again, 2 pi is a full rotation, so 1 pi would just be a half rotation, right? So kind of 180-degree angle or across my, right? Thinking of this too as my circle, so about a half rotation. And then my coordinates of my point, does this look familiar? Maybe, I hope, because the example we just did actually is coterminal with this, meaning it ended up in the same place, right? The last one was kind of 1.5 rotations. This one's just a half rotation. So technically, 9 through 12, the answers are going to be the same as the example 2, what we just did, because it ends up same coordinates, same radius. They're all going to be the same. Okay. And then 13 and 14, different angles, so same idea. And 13 and 14. So draw your graph. Find those. Okay. So just, guys, we have so much time. We have like 15 minutes. So, I'm happy to do any of these with you that you want,